So previously, I have introduced to you one of the ways in solving end moments and internal moments, no, by using three moment equation. So karon I will introduce to you another method in computing moments at supports, whether fixed ba siya or simple support. Okay, so this method was originated by Hardy Cross in 1930. It is called the moment distribution method. In moment distribution method, all types of statically indeterminate beams and rigid frames can be analyzed, in which bending is present, no, or the beams are subjected to bending. Okay, so isa sa mga concept niya, isa sa mga pinaka-importanting bantayanan nato is the rotation of the moments. So it is considered na ang leftmost part sa indeterminate beam or indeterminate structure is a negative moment. It is in clockwise rotation. Okay? So every time nga clockwise itong rotation, consider na to siya as a negative moment. Mo tong bantayan sa moment distribution. Kung ang rotation is counterclockwise, then it is a positive moment. So ang ato lang pong tan-awon is that kung mabantayan na to, pag nasa sa left gani nga moment or left support, negative siya, negative moment. And if nasa sa right, that is a positive within the span. Okay, within the span. So lahi na pud nga span, say for example kani nga makita karon nga tulo ka span, sa span in which uniformly distributed load ang gi-apply, negative moment ang nasa left, then positive moment ang sa right. Pag move na pug ka dito sa span in which a concentrated load is applied, negative moment ang left, positive moment ang right. Same goes with the triangular loading, negative moment ang left niya, considering one span lang ha, then positive moment ang right. Okay, so procedure in applying the moment distribution method. So first, let us assume that all supports to be fixed and compute the fixed end moments. So unlike the 3-moment equation in which kung kuhaon nimo ang 6a1a over L1 and 6a2b over L2 by analyzing one span and considering them each of them as a simple support, ang sa fixed end moment imo i-consider nga each span is fixed ended. Okay, take note of that, fixed end. So unlock each support and distribute the unbalanced moment at each one to each adjacent span by applying the distribution factor. Okay, so later atong i-elaborate nino sa mga distribution factor, what is an unbalanced moment. Mato lang ma-discuss ug mas pasabtan kung natay example. So after distributing the unbalanced moment to each adjacent span, carry over half of this amount with the same sign in the other end of each span. So this completes one cycle. The process should be repeated to be more accurate to at least 4 cycles. Okay, so pwede nimo i-repeat ang cycle. So atong i-discuss on sa puding cycle. Okay, so let's first ako sa siyang isulat, no, unsa ang mga steps to analyze moment distribution. So step 1, okay, okay, so step 1 is to determine the relative stiffness. Okay, stiffness. Unsa ning relative stiffness? May kag stiffness or beam stiffness, it is the ratio of your moment of inertia and the length. Okay? So, is the ratio kono of the moment of inertia to the length. Okay, so mas stiffer ang imuhang beam kung gamay ang imuhang dimension, di ba? Moment of inertia refers to the dimension of your structure. So kung gamay ang imuhang dimension, niwang bali siya pero taas ang ihang length, so makaingon ka nga stiff siya, no? Habog. Kung maingon pug ka nga dako ang imuhang moment of inertia, naggamay ang imuhang length, mubo siya pero tambol, so may ka nga dili ka siya nga naka-stiff. Okay, so ang formula for solving the relative stiffness is K is equal to I over L. But for modified stiffness, when you say modified stiffness, K is equal to 3/4 of I over L. So ano yung modified stiffness? In modified stiffness, ang ato ang beams once ngang iyang far end is hinge. So it is assumed that kung ang imuang support is hinge at the farthest end bali niya, diba, na makay series of supports. So sa farthest ends, kung hinge siya, it is assumed that 3/4 lang siya, 3/4 lang sa strength niya compare sa fix. So meaning mas lig-on gyud ang structure kung fix. Okay, 3/4 naman ang strength sa simple support. Okay. Okay, so step 2, once na makuha na nimo ang relative stiffness, the next step is to compute the distribution factor. Or DF. Okay. So, distribution factor, once nga imuhang end is a pin or a ruler, DF for pin is equal to 1. Ruler support. But if your support is fixed, so distribution factor is 0. Okay? So sa mga joints, kaya sa mga ends ni siya ha, pero sa joints, sa internal nga mga supports, so joints with 2 or more members, DF is relative stiffness. So katong sa ibabaw, no, relative stiffness over summation of the relative stiffness. Okay, so relative stiffness of one span divided by the summation of the relative stiffness of all the spans. Okay. So what's next? So na kay step 1 o step 2 in computing. Step 3 is to determine the fixed end moments. Step 3. So compute the fixed end moments. Okay. So what are fixed end moments? Fixed end moments are katong mga moments niya nana siya mga formulas, no? So dili na nako kinahanglan ipa-derive pa sa inyo kay sa kadaghan sa kataas sa koan, I mean sa exam, sa kadaghan sa inyohang mga kompyutonon, it would take time to derive. So it is more important to memorize all the fixed end moments. Isa na sa mga pinaka-importante sa structural analysis, to memorize the fixed end moments. So here akong ihatag sa inyo ang different fixed end moments depende sa load, no? Sa load nga gi-apply, applied load. So again, whatever the load is, it is considered that each ends are fixed. Okay, we have formula for concentrated load at a distance A from left. We also have a formula for concentrated load at the center or the midspan, for uniformly distributed load all throughout, and a uniformly distributed load at half of your beam. We also have formula for triangular loadings, okay, and for bended or deflected beams. Okay. So, imo lang ng subayon pag nasa left ang imong gi-analyze, so that is a negative formula, negative value. Nasa sa right, that is a positive value for fixed end moments. So that is step 3. Okay. Step 1, step 2, and step 3. The FEM. Okay, so what's next? We have step 4. So once na makuha na nimo ang mga fixed end moments, the next step is to balance the joints. So how to balance? Balancing joints. Ako na lang siya gibuhatag formula para mas easier ninyo masabtan. Okay, so it is the negative of the sum of the fixed end moments sa kana nga joint or sa kana nga support, sa isa ka support, multiplied by the distribution factor. Or you just have to convert the sign. Kung positive siya, ma-negative. Kung negative siya, ma-positive. So that is the way, you know, summation of fixed end moments multiplied by distribution factor. So mas masabtan natin na yun kung natay example. Okay. So next, step 5. For the step 5, we have the term carryover moment. So kaning carryover moment kibali once nga na kay indeterminate beam, ang load sa left, ang moment sa left can cause rotation or moment also sa pikas nga support, no? It doesn't mean nga kung sa tong moment sa imuhang left support na remain ragid na siya dito, more effect niya sa left, it would be distributed to the other support. So nga connected tanan moments, even if long kayo imong span, distributed ang moment in such a way nga ginatawag na to carryover moment. So COM or carryover moment is dividing the balance joints, no, or into two. Once na balance na nimo siya sa ibabaw, divide nimo siya into two. That is the carryover moment. Okay. So kaning step 5 and step 6 mo na gitaw na to og one cycle. Mo tong gingon kaina nga you have to repeat into more than one cycles up to 4, at least 4 kung ibali mo makaya niyang mabutog 4 cycles para accurate ang imuhang moment. Okay, so kani sila duha. This signifies the one cycle. Step 6. Okay, step 6. Just repeat the cycle. So there's cycle 2, cycle 3, cycle 4 na para makuha nimo ang yang more accurate nga value. Balik ka ni sa 4, next is 5. So step 7, pinaka last na step is to sum up moment. I-add nimo tanan moments, so that is the final moment. You will end up with the final moment value. Okay, so maghatag-tag example, no, para mas masabtan na to siya. So you just have to memorize all the steps